Thanks for coming and choosing me over the food. I hope you already had your lunch. And I know otherwise it's going to be a little bit of an uphill battle for me, competing with the lunch out there. Um, Stay in Java is my topic. Thank you for joining me, and thank you for the DevOps to give me the opportunity for this short talk to share my ideas. I'm Stefan WALD. I'm working for a company called Basis International, and I'm located in Germany, so I'm coming in to you from Germany. Company is headquartered in the US, and we're doing software development tools and frameworks since the 80s. And actually, if you see 30 plus years in development, I'm also already seen quite a few things before Java was even there. I'm with the company for more than 20 years now. So developers are basically the group of people I'm dealing with on every day, and I'm trying to make everybody's life easier and better and nicer and shinier. So when I started to develop, things used to be very easy. So I learned developing in a basic dialog when I was at the age of 17, and I brought you a picture. This is basically an official picture from the school when I was about that age. So this is me there, and you see things were easy in Germany. We didn't have school uniforms, and even this is the official picture. You see the guy there has a cigarette in the so, and this went through, so it was even in the yearbook. So things were really easy, and that was about the age when I started to get my first computer. It was a gift from my auntie, and I started to develop and did my first piece of software. And software of that time would have looked like this. So character-based interfaces, and this is, I wrote this in preparation for this talk, is a simple CRUD application. You give a customer ID, call up a record, let the user change it, and save it back. And this is a 30 lines of code. And software like this was in use in the 80s, in the 90s, and so on. So it started like that, and things were really simple. Of course, these were the times of spaghetti code. So I'm sure many of you here in the room, they currently suffer from having to look at code that was written at that time, maybe not having object orientation and stuff like that. So having it easy doesn't necessarily mean being in a good paradigm. But having said that, well, it was easier. But if you look at the landscape today, we looked up here an interactive graphic by the Cloud Native Computing Foundation, which lists a little bit the tools and frameworks and stuff that you can use to kind of host, deploy, maintain, develop a current cloud native application, perhaps with microservices, React frontend UI or whatever. And it's hundreds of things you can choose from. And this makes life of developers quite a little bit more complex than it was for me when I was learning. So today already when you're a student and you're getting in touch with IT for the first time in your classes, you have to learn many, many more things that I did have to learn to start coding. I mean, we pulled up the interpreter, started to code, and that was it. So life for the developers has become much more complex than it was at the time. And in my observation, we know that complexity kills a little bit of productivity. And I found a few quotes, and look here, there's even one from 2005 that Lotus Notes creator and also former Microsoft veteran Ray Ozzie did. So he said, it sucks light out of developers and it introduces security challenges. And nota bene, this was in 2005. I also found two more recent ones. So this, I like that one. It's funny a little bit. Emily Freeman, head of product marketing in AWS. Development today is a study in entropy and it's not getting any more simple. So in a way, these quotes from more or less important people also confirm my perception that it has become overly complex to develop. And another longer one, I'm not going to read that out loud to you. It has never been more difficult to be a software developer than it is today. And I think many of you share a little bit that feeling that, well, yeah, you have a feeling constantly not to be ahead of things. You always find out that there is the next new thing around the corner and you have the fear of missing out or making the wrong decision. And also maybe sometimes decisions get delayed because the decision makers thinks, okay, I have to wait because maybe this is not the optimal one, and the optimal solution might come around the corner just tomorrow. But when we're looking at complexity, we have to distinguish between essential and accidental complexity. And what do I mean with both? So essential, in my definition, is the complexity that you have to deal with in order to solve the problem of the business. Let's say you have to print an invoice, so you have to list items and calculate the totals and print them out. So this is essential, and if you ask to write code to solve that problem, you will have to solve that problem. And with accidental complexity, I mean the complexity that is introduced into an ecosystem, into a software, into a project by making certain choices that may seem to be a good idea. They may seem to be a shortcut to facilitate things, to be getting you quicker results, but that in the end kind of don't pay off that much, but that basically produce more complexity and produce a little bit more daily challenges when it goes further down the road. And I don't know, some of you may be working in a team where you had experience that you have new team members, and they come up and say, hey, why don't we try this and this and this? And then if you as a manager don't kind of manage this and say, yeah, show me, but then carefully decide based on what you're seeing. And if you're allowing everybody to just work with whatever comes around the corner, then you will end up with a zoo of little pets that you have to kind of feed in the future and busy yourself with, which basically can produce more and more clutter in your infrastructure. And so I would say be careful with what you want to let into your life, make a good decision here, and avoid accidental complexity in whatsoever aspect. So now coming a little bit more to the topic, stay in Java, what do I mean with the title of this talk? So almost reflexively today, if you have some Java in the business, like let's assume you have Java Swing or JSP or one of the frameworks that have been a little bit outdated, and you want to modernize the UI, almost reflexively, you would perhaps reach to a React or Angular or whatsoever web framework connected to your backend. You would have to do a perhaps Spring Boot REST web service type thing to connect to your UI. And this is what many companies nowadays do and strive for. So you would basically produce a front end in a JavaScript, TypeScript type environment and retain the backend in Java and use a Java library to produce your REST web services. What I'm like to kind of point your attention to what also would exist as an alternative would be that there are today modern frameworks that allow you to do the front end and the back end both in Java, so that the Java developer who oversees the logic can reclaim the control over the UI for perhaps not writing the next best TikTok app, but this is seldom what we're dealing with. So, but if you think about business applications, the knowledge about the business domain is very often in the hand of the back-end developers. And with these type of frameworks that allow you to do the front end and the back end in Java directly, you can give these people you can empower these people to basically do also the forms and the grids and all the things themselves. And so I had a developer of my team just in preparation for this talk do a little bit of a research. So I asked him to write the CRUD application that I wrote in Characterbased initially, once in React and Spring and once in the framework we have, but you will find others down there on the floor. So that would allow that Java only one stack approach. And so he listed the steps that were necessary for him to do this CRUD application. And he listed basically what he had to do on the React side, what he had to do on the Spring side to connect to the database, expose the REST web service, and all these things. And then I asked him to compare with the framework that we represent, or the result would be similar for any other framework that allows you to do a one-stack development. And interestingly, this developer came to us with a React background. And he was a recent hire, so he's not too long on the team. And he also had this impulse to say, well, I built that quickly in React for you because I'm so much faster. And for him, this experience was an eye-opener. I could observe that. He said, well, yeah, so if I really consider the full stack that we're creating, also keeping in mind that in your backend, you sometimes have very explicit logic that you have to follow. And then if you think about having to wrap a REST web service around everything, then you may end up with just too much work. And so he proved here that it was fewer steps, and the result looked in both ends pretty attractive. The name of the guy was Elias. You can figure from the demo data, from the sample data he used. So, and he compared the lines of code. So total lines of code with the React.js and Spring solution would be 230 and 659 for the React. We were just measuring what was the output. And for our solution, it was 376. And then written by the developer after the scaffolding. We know that React scaffolds quite a substantial amount of lines of code. It was still 152 plus 412 on the mixed stack side and 284 on the pure Java side. Where you can already see on a side note, I opened the parenthesis, object-oriented code always leads to more lines of code. So what I was able with a strict spaghetti code approach in a few lines of code, he still had to produce substantially more. And the approximate development time was also a little bit more because he had to scaffold two projects and work with both sides. And this might not be empirically done because I only had one guy do it and not 100. But it is showing our experience in the comparison. And so this is how a typical Java program in a one-stack tool set would look like. On the left, we're seeing a Java program that leads to a web app like this. It's a simple counter example. So the code for this example that you would have to write in Java is not more than this. You create a frame, which is basically the form itself. You add a text and a button. And then on the Java side, you register the event for clicking the counter button, and then when you click the counter button, we count up the counter and do a set text, which in turn tells the client to update the DOM for only this DOM element here. So this might be a very naive sample, but it shows very nicely how you can regain the control of everything on the Java side. Because if you think about it, in that click event, you might now just look up some data, perhaps check the credit limit for the customer. You do your web service call, look up the database, whatever, and then you just update this little DOM element. So you don't have to expose a ton of things in a REST web service. You do just everything in a lean kind of update to the DOM and have your entire logic in control on the Java side. So what do we gain with such an approach? I mean, this approach is not for everyone, but whenever you come from an existing Java ecosystem and you have a team that has the expertise in Java, considering such an approach might help you to keep the expertise limited to fewer technologies. So you wouldn't have to hire or train people in React, Angular, or whatever, and you can reduce the number of developers needed. Also, the communication. I mean, I'm sure some of you observed front-end developers bug fixing hand in hand with back-end developers, and one says to the other, it's your problem, and then he said, no, it's your problem. I see some of you nodding, so that's a common story we observe more and more. And so reducing the finger pointing and making the management of a team is going to become much, much simpler. So I'm over before the time is out. It's almost out, but a good talk is over before you wish it would be over, which leaves me a little bit of time to answer your questions now. Or if you want to chat with me about what I have proposed to you, just see me downstairs on the exhibition area. I'm here today and tomorrow to take your questions and enter discussions. If you have another opinion, I also want to hear it. So see me. Thank you for your attention and enjoy the rest of the conference. Thanks for having me.